All right, so again, today we're going to do what is called the rational root theorem, which will carry through for at least Friday, possibly Monday as well. But you're going to go right on over to your notebook. And we're going to start right with what the rational root theorem is. And again, I want you to have a calculator in front of you as well. All right, so this is section 4.4, known as the rational root theorem. All right, rational root theorem. So when all is said and done with these, you are going to be finding all of the roots of a polynomial. Okay? Some of these will be rational, some of these are going to be your imaginary roots that you're accustomed to finding too. So the rational root theorem definition. So say you are given a polynomial. You may abbreviate anything you see necessary. So I'm going to say given a polynomial. If a rational number, I'll abbreviate when I can. P divided by Q, and we'll talk about what that means in a second, is a root or zero. Is a root, which means the same exact thing as a zero. Then P is a factor of your constant, which is algebraically denoted as a sub 0. Again, I'll give you examples of all of this. And Q is a factor of the coefficient of your leading term, which is denoted as a sub n. Okay. So here's an example of that. So say, for instance, we have P of x for your polynomial equal to, and I'm going to go 3x squared and then plus 2x plus 4. All right. So the 4 represents the constant. So this is a sub 0. So this is always going to be your P. And what you'll be doing is you'll write out factors of P. Then up here, my 3 is the coefficient of my leading term. So that is a sub n. And that we represent as the letter Q. So those are the two numbers that we're going to pay attention today. And you're going to take them and you're going to create a list of what we call possible rational zeros. Then you're going to make use of your graphing calculator and synthetic division to determine which of those actually work. That will reduce your polynomial and allow you to find any irrational roots or imaginary roots. Okay. So I'm going to begin here and I'm going to attach the first question onto this. And what we want to do is we're going to create a list of possible rational roots. So I'm going to say find all possible rational roots. So find all possible rational roots. Okay. So in this case, I'm just going to walk you through. We're going to do what is called the factors of P over the factors of Q. So I'm going to list out the factors of P divided by the factors of Q. And then we're going to put the list together. All right, so factors of P. So I'm going to look right here at P. And you're going to ask yourself, how can you get 4? What multiplies to be 4? 1, 2, and 4. Good. And what I do for all of these is I put plus and minus in the front. So factors of 4 are 1, 2, and 4. That's the only way you can make that happen. I'm going to do the same idea with Q. How can I get 3? What's the only way to get 3? 1 and 3. Good. So also plus and minus, which goes with all those 1 and 3. Okay. So this is just a list of possible rational roots. I'm going to actually do this because we're not actually going to find them all until later down the road. So I'm going to just say list possible rational roots. And we'll kind of ease into this a little bit. So then what I do is I create a big list out of this. So I'm going to put my plus and minus in the front. And then I'm going to just list all the combinations. So to do this, I am going to take the top here and I'm going to do 1 divided by 1, which is just still 1. Then I'm going to do 1 divided by 3, which is 1/3. Because remember, 1/3 is rational. Now I go to the next number. So I go to the 2. 2 divided by 1 is just 2. 2 divided by 3 is 2/3. 4 divided by 1 is 4. And my last combination would be 4 divided by 3. Okay. So what this means is this particular polynomial would have 1, 2, 3, 4, 5, 6 times 2, because you have the negatives, 12 possible rational roots. Okay. So this would have 12 possible rational roots. So some of your homework questions are just simply going to ask you to do that, just to list them. So 12 possible rational roots. Okay. So let's jump in and give you another example. So now I want to go. I'll say number 2 here. Let's say that we have f of x instead of p of x equal to, and let's go 2x to the 4th power and minus 5x to the 2nd and minus 3. This is a degree 4 polynomial, which means when you actually go to physically find them all, how many roots would you have? 4. Good. So this again is going to have 4 roots once you get to that part. Right now, all I want you to list out are just the possibilities. So we're going to make a list of possible rational roots, because once you get these lists, you're going to have to test these. So a list of possible rational roots. And then after this one, we'll kind of start putting more of it together. So I'm going to do the factors of P over the factors of Q. So factors for P over the factors of Q, and you're going to generate your list. Factors of Q. Okay, so for P, how can we obtain 3? Just 1 and 3. So those are the factors of 3. Nice and short. The negative, yes. For that purpose, yes. So then the 2, I'm going to go 1 and 2. So would you guys agree this is a smaller list? Much shorter. So the possibilities here are going to be plus and minus, or you can choose to write them all out if you want. And I'm going to put them together. So I have 1 divided by 1, which is 1. And then I would take 1 divided by 2, which is 1/2. Next, 3 divided by 1 is 3. And then my last possibility would be 3 divided by 2. Okay, so how many possible rational roots would this have? 8 possibilities. Yep, so 8 possibilities. All right. Do you think you need another where you're just listing them, or are you ready to jump in? All right. So I'm going to skip here and we're going to now find them all. So I'm going to say number 3. Find all possible rational roots and imaginary roots. So not just list, but find all possible rational and imaginary roots. Rational and imaginary roots. The higher the degree, the more work you have to do. So this first one, I'm going to start with just degree 3. So I want to go f of x equal 2. And this is going to be x cubed. And then I'm going to go plus 6x squared. And then minus 13x and minus 6. So this is a degree 3 polynomial. So when we are done, how many possible rational and imaginary roots should we have? 3. So again, this is going to have 3 roots when all is said and done. First thing we do is make a list of possible rational roots. So here is my p. Here is my q. And I make my list. So I'm going to go factors of p over factors of q first still, so that does not change. So factors of p and then factors of q. All right. So in this particular instance, 6, we have more factors. Factors of 6 are going to be, yep, go ahead, say it again. 1, 2, 3, 6. Absolutely perfect. What the nice thing about x cubed is, what's the factor of 1? So here's your list. Positive and negative. And then we're going to test these. So you have 1, 2, 3, and 6. So you have 8 of these all together. And what you want to do is figure out which ones actually work. So there's 2 ways to go about this. We do not take your calculator away from you. So you're going to be able to use your calculator to verify this quickly. To determine if something is a factor, what you did 2 days ago was called the factor theorem. How did we determine if these were factors? What did we do? Synthetic division. So you can make use of synthetic division. And if something is a factor, what should you obtain? Remainder of 0. Good. Remainder equal to 0. So if we took the calculator away from you, how many times do you have to do synthetic division? 8. Okay. We're not going to do that. We're going to graph this and we're going to figure out at least one place where one of these works. Okay, so we're going to grab the graphing calculator. The list is just the possible ones you check. It doesn't mean they work. Yep, because that one would only have 4 that actually work. Yes, but those are possibles. They're possible ones you check. They don't all. You get what I'm saying? Yep. Good question though. So again, instead of doing synthetic division in this case 8 times, what we're going to do is graph this and see if we can find one of our rational roots and go from there to simplify it. So you're going to grab your graphing calculator and you're going to type in the original. Unless, of course, you want to do synthetic 8 times. No takers. So in your y equals, you are going to type in your original function, which is x cubed plus 6x squared minus 13x minus 6. Now, when you hit graph, you are going to look for the places where this crosses the x-axis. And what you're going to do is you're going to look at the list that you just created as a benchmark to help yourself. So the list we just created said we have possible rational roots at 1 and -1. Well, does it look like those work? Nope, doesn't cross there. We have possibilities at 2 and -2. Does -2 work? Definitely not. What about +2? So verify this. At +2, are we 0? So guess what? That works. So now I'm going to go back to my paper. And we are going to synthetically divide the one that we know with certainty works so that we don't waste our time doing the other 7. So we know for sure that 2 works. Why? Because we verified that on the calculator. I'll do that for just your notes. So I'm going to do 2 divides into. I have 1, 6, -13, and -6. So the 1 comes straight down. 1 times 2 is 2. Add and I get 8. 8 times 2 is 16. Add and I get 3. And then 3 times 2 is 6. But again, didn't you kind of cheat a little bit and you knew it was going to work? Yes. So of course that should have worked. We verified it on the calculator. So now what you are left with, you have to work with further, is I know if 2 is a 0, then x minus 2 is the factor. Just like what you did 2 days ago. Was this p of x or f of x? F of x, thank you. So f of x equals, and now this. I am left with a quadratic because we did division. So we are now left with x squared plus 8x plus 3. Okay. If you think back to your screen on the graphing calculator, did we have any other rational roots that we saw that were nice? I don't believe we did, right? Okay. So when you look at this quadratic right here, does this factor? Multiplies to 3 and adds to 8. It does not factor. So to get the other 2 remaining roots, you're going to have to do what? Quadratic formula. Very good. We have one of our 3 roots. We need to find the others, which means that these are probably going to be irrational or imaginary. So this only helps you find the rational. And then you're going to have to apply a different strategy to find your others. So we're going to now do quadratic formula. So x is equal to -8 plus and minus the square root of 8 squared minus 4 times a times c all over 2a, which is just 2. So x is equal to -8 plus and minus. And I'm going to keep going on this. Does someone have that value underneath yours? 52, thank you. So I have 52 over 2. And now I'm going to continue. So this particular instance, we do not have imaginary roots, but we are going to have irrational roots. So we break the 52 down as far as we can, and then we're done. So what is the largest perfect square that 52 is divisible by? 4. Good. 4 and 13. Divided by 2. So now I'm going to finish this, and we're going to list all of our roots. We have x is equal to -8 plus and minus 2 radical 13 over 2. And do I have to continue? Yes. You got to simplify this. You must. So x is equal to -4 plus and minus the square root of 13. And that stands for 2 irrational roots. And again, just like with those imaginaries, these always come in pairs. Okay, so we're done. Let's just conclude this. So it said find all roots, and it says your rational and irrational. So we have 3 roots. Again, we had 1 rational, 2 irrational. And then I'm just going to list them. So our answers were, I'm looking for it, 2, and then -4 plus and minus the square root of 13. Okay. So just goes like that. All right, how is that problem? Okay. All right, let's do another. So next, I'm going to give you just a cubic. Okay, so if I give you a cubic, how many roots are we looking for? 3. Good. Obviously, as it gets bigger, you have more work to do. So let's go f of x again. Equal to, and I want to go x cubed plus 4x squared and plus 4x plus 3. So you're going to find them all. Okay. First, I want the list of possibilities. So here's P, here's Q, and this is a nice small list, isn't it? So you're going to go factors of P over factors of Q. And then you check your calculator and figure out which ones actually do work. So factors of P, factors of Q. All right, factors of 3 are going to be 1 and 3. Factors of 1 are, can't get much easier than that list, right? So this is equal to just 1 and 3, positive and negative. So when you pick up your calculator right now, we're looking for, do we have a 0 at 1, -1, 3, -3? So again, you're going back to your calculator. Or this one, as far as your synthetic, you would only have to do it 4 times. Or maybe if you're really lucky, you would, get some of them right away. All right, so I'm going to type my function in here, which was x cubed and plus 4x squared and plus 4x plus 3. You know exactly where to look around. It's, right off your possible rational root list. And what looks like it works here? -3. Nothing else is even going to cross there. So this particular question has only 1 rational root, which means 2 of them are probably going to be what? Irrational or imaginary. All right, so we're going to divide out -3 now because we just showed that that works. So on the calculator, -3 was a 0. So I do -3 divides. This is not when you flip the sign. You only flip the sign when you have the factor. So I'm going to go 1, 4, 4, 3. That comes straight down. -3, 1, -3, 1, -3, 0. Again, these are supposed to work. At this point, I have f of x equal to, now I flip it, x plus 3. And then what results is x squared plus x plus 1. And I need to obtain my other 2 remaining roots from that quadratic. Does this quadratic factor? Nope. Always check that first. not factorable. Therefore, we need to go to quadratic formula again. So my procedure is going to be quadratic formula. The faster you can do this, the better. Will obviously be precise and accurate. So I'm going to go x equals -1 plus and minus square root of 1 squared minus 4 times 1 times 1 all over 2 times 1. So x is equal to -1 plus and minus the square root of 1 minus 4, which is just going to give me, yep, -3. It's going to just save you a little bit of writing. And then over 2. Okay. What type of roots is this question going to produce? Imaginary. Yep. And again, those are not visible on a graph. So x is equal to -1 plus and minus I radical 3 all over 2. And then I would like a conclusion. So we have 3 roots. We had in this particular instance 1 rational, 2 imaginary. Remember, imaginary always come in pairs. So, and 2 imaginary. As they were. -3. And then -1 plus and minus I radical 3 over 2. And again, most of these you will notice are going to work with quadratic formula after that synthetic. Okay. How do we feel with those so far? Not terrible? Just a little bit lengthy. As we get into larger degrees, your problem just becomes a little bit, longer. Sometimes you have to do synthetic twice there. Go to those now. Okay, I'm going to give you a little bit of time to start homework then. Because we're going to practice more of them tomorrow. Your homework are on page 234. You are to complete, just because I know I didn't write it up there. On page 234, you have 10 through 13 and then 15 as well. The first couple questions might simply say list the possible rational roots, not find them. Okay, so pay attention to that because they're not all the big, long questions.